Hi, this is Mrs. Mancuso, and today's topic for our Regents Review is covalent bonding. So when you have covalent bonding, you have two nonmetals, and this means they're going to share electrons. So their valence electrons will be more stable if they share them. So we can think of an example like water, H2O. Oxygen, if I go ahead and do its Lewis dot diagram, I go look up oxygen on the periodic table, and oxygen's electron configuration is 2-6. So that tells me I need 6 electrons on it. Spot 1, spot 2, spot 3, spot 4, spot 5, spot 6. So that's the electron configuration and the Lewis dot diagram for oxygen. So it was 2-6. I use the 6 valence as the 6 dots. 2 hydrogens, it's so easy to notice the 2 spots that they'll go in. So I put one H here and one H here. When I follow the rules, it makes it really easy for my diagram to be correct. I should never draw this hydrogen over here. Its actual shape is bent. When it is bent, that is showing me that it's asymmetrical. And when it's asymmetrical, this is a polar molecule. That means this molecule has an uneven distribution of charge. This and this, the 2 hydrogens, will have a slight positive charge. Look at these electrons. These unshared pairs of electrons make the oxygen side of the molecule very negative. So that is why this molecule is unevenly distributed, asymmetrical, and therefore a polar molecule. If I think of something like another question that they would ask you, it would be, what is the polarity of the bond? So here we were talking about the molecule. If I wanted to know the bond, I'm asking just about this HO bond. So what I have to do is I have to look up electronegativity difference. So I go back to my reference table. The table after the periodic table lists electronegativity. So I'm going to look it up. Electronegativity of H is 2.2, and electronegativity of O is 3.4. The difference between 3.4 and 2.2 is 1.2, which is very polar. As long as it's 0.5 or higher, it's going to be a polar bond. So water has polar bonds, and it is a polar molecule because it's asymmetrical and it has an uneven distribution of charge. Let's think of something that's nonpolar. If it's nonpolar, there's no pull. That means equal sharing of electrons. If there's equal sharing of electrons, the electronegativity difference is going to be very low. It is going to be less than 0.5. So I want to think of a molecule like CH4. First of all, here's my C. It has a configuration of 2-4. That means I want 4 valence electrons. Carbon has a unique rule. You can actually put its 4 valence around in a circle like that. That means I would have 1 H here, 1 H here, 1 H here, and 1 H here. This is very symmetrical. This has an even distribution of charge. There's no pluses or minuses on the molecules, which means this is very non-polar molecule. Now, if I want to look at the bond, I want to look at the electronegativity difference. So I'm going to look up C and I'm going to look up H. So I go back here. H is a 2.2 and C is a 2.6. The difference between it is a 0.4. So again, that's less than 0.5. So this is a non-polar bond. Molecules that are nonpolar have very weak attractions to each other because there's no charges to be attracted to. These molecules tend to be gases, so think of the most spread out things. They don't have attractions to each other, so they spread out. So these nonpolar things tend to be gases. They have no need to bond or join with any other molecules, or they don't have attractions between other molecules. It also means they're not going to be good electrolytes. They're not going to be good at conducting electricity. So if we just did a quick comparison of polar versus nonpolar, polar bonds have an electronegativity difference that is greater than 0.5. Nonpolar bonds have an electronegativity difference that is less than 0.5. Polar molecules tend to be asymmetrical, and they have an uneven distribution. Nonpolar molecules tend to be very symmetrical and have an even distribution. Polar, the electrons are not shared equally. And nonpolar, the electrons are shared equally. So I always say polar has pull. So this molecule, there is a pull from one side to the other. So for example, HCl, Cl has more pull, so this side is negative and this side is positive. Because there are charges, it makes a good electrolyte. And it has stronger IMFs. That means it tends to be more on the liquid side, like water has hydrogen bonds, so it's got more pull and it tends to be more of a liquid with a higher boiling point. Nowhere near anything ionic, but covalent's always going to be lower. This one is going to have super low boiling points and melting points, and that's because there's very weak IMFs. There's no charges, so there's no attractions between molecules. So nonpolar, I can think of oxygen with oxygen. This would need electrons here. There is a very symmetrical molecule with no pull, completely even distribution of charge, though this is a nonpolar molecule, tends to be a gas. All right, thanks for joining me for review, and join me next time.